Hello, algebra students. Mr. Lawrence here with part 2 of your review video, and this part is going to be a little bit longer, and I might actually go into part 3. That way the videos don't take up too much time. You can watch them in parts if you like over a couple of days. You can rewatch one part more than once without having to watch the whole thing. Anyway, it might be more convenient for you. All right, well, let's get down to this. Sorry if I sound like I'm in a hurry, but I had to do this video. The computer shut off on me before it finished saving, so I got to redo it, but that's okay. You guys are worth it. So let's see here. Let me get my calligraphic pen. And I've got to solve equations with fractions. Now, I know a lot of you are going to want to multiply through right away by 15, and I think that's a great idea. But I know some of you are going to go, hey, Mr. Lawrence, I want to subtract 5 as my first step. And I think that's also a great idea. And I'm going to do problem number 7 by getting rid of one of those constants first. And then I'll do problem 8 by multiplying first, and maybe you can see why I chose to do problem 7 the way I did. It'll make it just a tiny bit easier, but it won't be wrong if you choose to multiply first. Okay, so now that I've got one of the constants off of one of the sides, like I said, I'm going to multiply through by 15. Why 15? Because it's the smallest number that both 3 and 5 divide into evenly. And when I do it on the right hand side, I have to remember to distribute. And so I'm going to multiply the 2/5 x by 15 and the 1 by 15. I'm going to write it long ways here for a second, just so you can see where I'm at after I distribute. If you can go right from this step to the simplified answer, I don't mind, but not everybody can. So I'm going to show you 15 over 1 times 2/5 x plus 1 times 15. And I didn't write the 15 as a fraction because 1 wasn't a fraction. All right, so I'm going to come over here to the left-hand side, and I'm going to look, remember all 4 directions, vertically left, vertically right, like that. And I'm going to see if I can simplify any of those fractions in those directions. And look at this, I have 15 thirds. That'll simplify to 5 over 1. Now my denominator turned to all ones, right? That's a good thing. I'll just ignore it from now on because when I divide by 1, nothing's going to happen anyway. So I'm not going to write it as a fraction over 1. Instead, I'm going to multiply my numerators, 5 times 1, and don't forget the x. 5 times 1 is 5 times x, 5x. All right. Over here, I'm going to jump over and do the 1 times 15 first. And now I'll look at my multiplication of my two fractions, 15 over 1 times 2/5. And again, I'm going to look all 4 directions, see if I can find a fraction to simplify. And sure enough, I have 15/5, which will turn into 3 over 1. Denominators are all 1. When they multiply, they'll turn into 1. I'll divide by 1. Nothing's going to happen. I'm just going to ignore the denominator. 3 times 2 is 6 times x, 6x. Okay, so I don't like having variables on both sides. I think it would be more direct to subtract 6x from both sides. Some of you are going to want to subtract 5x, and you can. Oops, I just told you what you were going to do, and then I did it. But you got to remember to keep that 0 in place. Okay, so the left-hand side becomes negative 1x, or I like to even just say negative x, and then the right-hand side becomes 15. Now we're not done because we're not solving for negative x, we're solving for positive x. Now I'm going to show you the math of this in a second, but just think for a second. If x is 2, what's negative x? Well, it's negative 2, right? If x is negative 4, then the negative of x is positive 4. If the side changed on one side, I got to change on the other. Well, if negative x is 15, what's positive x? Well, it's going to end up being negative 15. Now, it's important to know that, but it's also important to know why that actually happens. And here's what we can say. What number is attached to x? Now, some of you are going to say the negative, but negative's not a number. How many negative x's are there? There's 1. So really, there's a negative 1 attached to x. How is it attached? Multiplication. How do I undo that? Division. And so the left-hand side becomes x, the right-hand side comes to negative 15, just like my little sidebar over there showed. Okay, let's go over here to this problem. And this one I will multiply through first. I'm going to multiply both sides by the smallest number that 4 and 5 will divide into. In this case, it's 20. Okay, now I got to remember to distribute. I got to multiply the 20 times the 3/4 and the 20 times the -2 and the 20 times the 1 and the 20 times the -2/5. So I'm going to write out what the multiplication looks like. I'm going to have 20 over 1. Let me divide this problem over here like that. There we go. Times 3/4 x minus 2 times 20. Notice I didn't write the 20 as a fraction on that one. And then I have a 20 times a 1 minus a 2/5 x times 20 over 1. Okay, now I'm ready to do some simplifying because my distribution is finished. I see I have 20/4. That will turn into 5 over 1. Denominators are all 1. I like it. 5 times 3, 15 times x, 15x. 2 times 20, 40. 20 times 1, 20. 25th turns into 4 over 1. 4 times 2 is 8 times x, 8x. There's a negative there, minus 8x. Okay, now I've got variables on both sides. I don't like that. I'm going to take away this negative 8x, which means I'm going to add 8x to both sides. Adding 8x. Whoa. All right, and that will get me 23x minus 40 equals 20. And I have a two-step equation. So I will add 40 to both sides. Shoomp, shoomp. Leaving me with 23x, it equals 60. And I'll divide by 23, and I'll divide by 23. So an answer, a good answer, is 60 over 23. Remember, a mixed number is an acceptable answer. Excuse me, an improper fraction is an acceptable answer. I know an elementary school teacher may have told you never leave an improper fraction. They're wrong. Okay, they're wrong. There are some times, especially when we get to slope, where improper fractions are the best thing to use. Now, if you're more comfortable with a mixed number, I don't have a problem with that. See how many times 23 goes into 60? I believe it goes in twice. I think that'd be 46. I'm going to be 14 short of 60. And that'll be over 23. And there you go. Either one of those answers. You don't have to have both, just one of them. You can put both if you want, though. All right, combining like terms. Now, the first thing I do on this one is I look at all my quantities. I notice that they're all positive. That means that the parentheses are actually unnecessary in this problem. So all I have to do, since everything is, all the quantities are positive, not all the terms are positive, but the quantities, I'll just combine my x's, and I'm highlighting them, making sure to grab signs that are in front of the coefficients or variables. And then I'll highlight my constants. I got a -6, and I've got a -10, and then a +5, right? And now I'm just going to combine. How many x's do I have? Well, I have 9 here. Take away 3, I must have 6 x's. For my constants, I have 6 negatives, 10 more negatives. I'm up to 16 negatives. Now I have 5 positives, and that will give me -11. Okay, so the answer is 6x minus 11. That's a simplified form of it. Now, on number 10, I notice I do have some negatives on some quantities. Right there and right there. That means for those two quantities only, I need the inverses of the numbers inside because there's a -1 attached to those quantities, and I need to distribute only in those two quantities. Now, you could argue that, well, Mr. Lawrence, there's a +1 in front of these quantities. Yes, there is. But if I distribute a +1, nothing happens because I'm just multiplying. So I'm not going to waste my time doing it. It's not wrong, but it's just a waste of time. It's totally unnecessary. Okay, so I'm going to just copy down the positive quantities without their parentheses because they're unnecessary. And I come to this quantity, time to distribute. -1 times 6x will be -6x. -1 times -3 will be +3. This quantity here will be x plus 12. And then with the last quantity, it's time to distribute. I will do -1 times 5x and -1 times 6. All right, now I can go ahead and start grouping. I'm going to highlight my X's in yellow, making sure to grab signs. Gotta grab the signs. I've got the signs. Okay, and then I've got my constants. Making sure to grab the signs. Don't forget to grab the signs. Those signs belong to the numbers they're in front of. All right, so looking at the yellows, I have 7 minus 6, which is 1. Another 1, which is 2, minus 5. That's a negative 3x. Now for the constants, I have a negative 4 and a positive 3. In fact, I don't even want to do it that way. You know what? I want to think about this. This would be 15, and then I have 10 negatives. 15 minus 10, wouldn't that be positive 5? And there you go. See, I just grouped my positives together, 15 positives, and then 10 negatives. 15 minus 10 is 5. This stuff is too easy. All right, solving literal equations. Remember on this one, we want to circle the variable we're solving for. So in this problem, I'm going to solve for t, and I'm going to ask myself what numbers are attached to t. Well, the p and the r, of course. Oh, help, I'm being squeezed by a 4-year-old Spider-Man. Anyway, they're attached by multiplication, so I'm going to divide. What am I going to divide by? Well, if it was x or 2x, you'd say, hey, Mr. Lawrence, I'm going to divide by 2. If it was 17x, you'd say, I'm going to divide by 17, right? If it was watermelon x, you'd say, Mr. Lawrence, I need to divide by a watermelon. Yeah, we're going to divide by PR because PR is what's attached to the t, and they're both attached by multiplication. So when I do that, I'm going to get I over PR, which will equal T. If you hear an echo, I have a 4-year-old shadow who told me to go ahead and make the video, and then he decided he was bored. So he doesn't even want to play on the iPad. Okay, so we have to solve for L in problem number 12. I'm going to circle the L. Now, there's a fraction there, and that bugs some of you. Well, look, let's go ahead and multiply to get rid of the fraction. Yeah, you know that. We're going to multiply both sides. Now, what are we going to multiply by? Well, if it was b over 7, you'd say, hey, I'll multiply by 7. Well, it's b over L. Let's multiply by L. And write the left-hand side as a fraction, and the right-hand side as a plain old L. The left-hand side, the L's will cancel. I'll get capital B will equal PL. Is L alone? Why, no, it's not. It's attached to a P by multiplication. I'll divide by P. Divide by P. And so the P's will cancel. I'll have capital B over P, which is equal to L. L is all alone, and I'm good as gold. All right, we're going to do problem 13, and then I'll cap the video. And then I'll make a short one with the remaining couple of problems. Okay, so we're going to solve for y. And I'm going to ask myself, what numbers are attached to y? Well, most of you see a negative 3 right away, and that's going to be attached by multiplication, right? Now, it's not a 2 attached to the y, it's a 2x. And it's attached by addition because the 2 is positive. So, I'm going to listen to Saddam, and Saddam is going to tell me to undo the addition first. And I tell you, the left-hand side is the hard side, really, because all you have left is a negative 3y, because you had to subtract there. The right-hand side, there's nothing you can do. They're not like terms. I'm just going to write them down. Now, some of you would have wanted to write down 9 minus 2x, and that wouldn't be wrong. But remember, I said that down the road, we're going to do something with an equation, and if the variable is first, it'll be easier to do it, okay? But it won't be wrong if you do 9 minus 2x. Now, I still have a negative 3 attached to y, and it's attached by multiplication, so I'm going to divide by negative 3. But on the right-hand side, I have to remember to distribute. When you're doing multiplication or division, it's a distribution situation. You have to divide or multiply all the terms by the number. Okay, so now I'm just going to simplify. These negative 3y's will cancel, leaving me a plain old y. Here on the 2x over 3, the positive, or the negatives are going to become positive, but the fraction will stay the same. And then I have a 9 divided by a negative 3, that'll be a negative 3. And look at that, I am done. Okay, I think that's long enough for this video. We still have to talk about a problem like this, and I'll show you 2 ways to do it, and one's kind of a shortcut. Natalie Zapka knows how to do it. Anyway, and then we have to talk about translating and solving equations and inequalities. So we have one equation and one inequality. And then that'll be it for the video. So we're going to end it for part 2 right here. Mr. Lawrence signing off. Good night, everybody.